The team decided to collect data on the units damaged each quarter since the first quarter of 1996. The spreadsheet below contains the raw data and part of the calculations necessary to compute the seasonal factors for a multiplicative model. So I compute the values represented by the letters on the spreadsheet and plot a line graph. So we have the first column showing the quarters, March, June, September, December for the years 1996, 1997, 1998, 1999, and 2000, first quarter of 2000. The units damaged are given. The moving average, quarterly moving average is given. Scented moving average is also given. Rough seasonals are also given. Deseasonalized data is also given. Now we have to find the missing values, which is A, B, C, and D. So let's do that. So the moving average. So the moving average, this 212, is the average of the four values. So 164, 231, and the value which is missing, represented by A, and 199. So the average of these values equal 212. So to find A, we type equal 212 multiply by 4. Then subtract sum of the given values 164, 231, 199, and that's 254. Let's make it bold. And for B, now so the moving average for the quarterly moving average is 2 past quarters values added to that particular quarter value and one future value. So to find B, we find average of 2 past quarters and one the value for that quarter and one future value, one future quarter. And that's 237. And the value for C, that's scented moving average. Now the scented moving average is the average of that for that particular quarter and one future quarter. Let's test some of those values for the second scented moving average. Okay. So the missing value is equal to average for the moving average of that quarter and one future quarter. And that's 211.55. And the rough seasonals are the units damaged values divided by the centered moving average. So let's test some of those values. So for D, we need to find, so that equals 348. So the units damaged for that particular quarter divided by the centered moving average for that particular quarter. And let's round that to 3 decimal place. Type round, bracket, 3, that's 1.149. Okay, now we plot a line graph. So click on Insert, click on Chart. Let's carry this chart to its own sheet. Let's edit the chart. So we want a line chart. So we want a straight line chart. For the data range, let's select the quarter and let's add another range. That's for units damaged. Let's do the selection again. Just click on OK. Okay, so we have a line chart now. So let's customize this line chart. Let's add the titles. For the horizontal axis title, let's type quarter ending. For the vertical axis title, let's type units damaged. For the chart title, let's type transportation damage 1996 to 2000. Then let's show the data points. So click on series and click on for the point size, select 7px, and the color, for the line color, select black. Now let's show the tick labels. So click on grid lines and ticks. For the vertical axis, let's let's select vertical axis. Put a minimum value of say 100, and click on grid lines. Show the major ticks, and let's choose the steps to be 20. And for the horizontal axis, let's show the major ticks as well. Okay. So the given data is up to June 2000. And now let's check the next question. Describe two major features of this graph. Let's look at the graph. We see the peak levels at September of every year. And June and September values are very close. And we also see the values are quite steady, but it starts to increase in 1998. So it shows the increasing trend. There is a regular seasonal variation with the September quota always highest, followed closely by the June quota. March and December quotas are much lower than these each year. So as we can see, December and March, they are quite low for each year. So for 1997, March is here, and December they are low. For 1998, March value and the December values are quite low. And for 1999, March value and the December value are quite low. For 2000, March value is quite low. So the March and December values are quite low, are much lower than these each year. There is also upward trend, fairly stationary for 1996 to 1998. So the trend is fairly stationary from 1996 to 1998, and then it shows upward trend. With an upward shift in 1999 to 2000. Explain briefly how might these features help us identify some of the possible causes of transit. We should look for reasons for upwards shift where there are changes made around the end of 1998. For example, to carriers, packaging, policy units sold. Also, damage higher during winter. So winter months are June and September. June So between June and September. So also damage higher during winter. Is this due to wetted condition or are sales higher during winter? So as we can see, the units damaged are quite high in June, between June and September, and that's the winter month. Compute the values represented by the letters A, B, C, D on the spreadsheet, which we have already done. The adjusted seasonal factors for quarterly damage are to 2 decimal places. Given as for March, the seasonal factor is 0.83, June 1.11, September 1.22, December 0.84. Confirm these by entering the rough seasonals and averaging for each quarter. Retain 3 decimal places. So we make a two-way table. The columns are labeled as March, June, September, December, and the rows are labeled as 1996, 1997, 1998, 1999. We don't include the 2000 because the rough seasonals, they are ending at December 1999. And now we want to put all those values, fill this table. So for September 1996, the rough seasonal. So March and June, there is no values available. So September and December, we fill these values in the table. And for 1997, we fill the values for March, June, September, December. So March, June, September, December. And for 1998, we fill these with the rough seasonal values for March, June, September, December. Okay, and same for 1999. So we fill the values for March, June, September, December. And then we calculate the average of each of these quarters. So for March, we calculate the average. For June, we calculate the average. And for September, we calculate the average. For December, we calculate the average. And then we calculate the overall average, which is 0.998. And then the seasonal index is that quarter average divided by overall average. And we can see that these values are same as the given values. So the seasonal index, this is how we find the seasonal index. Why do we always need to adjust the seasonal factors calculated in B above? So the seasonals are adjusted to average exactly 1 or sum of 4. On the graph of the quarterly transport damage, plot the centered moving average and extend out to March 2001. Okay, so March 2001. So we in the table we have added up to March, the quarters up to March 2001. Now we want to add this to the line chart. So click on edit chart, add another data range, and that is for centered moving average. Okay, then go to the series, click on add series, and add centered moving average. Okay, so what we want to do is we want to add the data points in this centered moving average. So let's show the point, increase the point size 7px, and we also want to put this legend on the right. So click on legend, and for the position, check right, and units damaged, and centered, for the centered moving average, CMA 4. Okay. On the graph of the quarterly transport damage, plot the centered moving average and extend out to March 2001. So let's extend this centered moving average to March 2001. So click on edit chart, click on customize, click on series, select trend line, type, select moving average, average type, select centered. Okay, so okay, so this is what we have done. We have extended the centered moving average to up to March 2001. Use this centered moving average and the seasonal factors above to obtain forecast for the next 2 quarters. September 2000 and December 2000 and plot them on the graph. So we can see in the table September 2000 and December 2000 there is no observed data. So we want to estimate, find that. We want to forecast them. Okay. So scented moving average forecast that will come from the graph. So for September 2000, it's in between 320 and 340. So let's take it as 330. And for December 2000 is nearly very close to 340. So let's take it as 335. And the seasonal factor. The seasonal factor for September 2000 is, for September is 1.22 and for December is 0.84. And then we multiply this scented moving average estimate. Okay, multiply scented moving average estimate by the seasonal factor to get the forecast values. And we have 402.6 for September 2000 and 281.4 for December 2000. So let's put these values here. Let's make it bold. Equal forecast value, press enter, and for December let's make it bold as well, equal $281.4. Now all the other values are to the whole number, so let's round this to the whole number. Round this, comma, we don't need to put any decimal places for rounding to whole number. Okay, so so it's 403 and 281 should be automatically added. Okay, so it's added. Now what we do is that we change these data point colors. Let's change that. Before we want to remove this error bars. Okay, and then for that, and fill opacity we want 10%, and point size let's make it say 10px, and point shape circle, and for the other data point as well, the forecast data point, 10% opacity, and the point size let's make it 10. So that's our forecast. Next question. On the spreadsheet above are the two letters X and Y in the deseasonalized data column. Calculate the values that they represent. Let's go to X. Now these values are the units damaged value divided by the seasonal value, seasonal index. So that's for March, the seasonal index is 0.83. And that's approximately 198. The next one is equal to 231, that's for June quarter, divided by the seasonal index for June. And that's approximately 208. Now for the missing value X, the seasonalized value, let's make it bold, equal the original data value divided by the seasonal index for June 1998. So seasonal index for June. And let's round that to a whole number. So put right round bracket, put that in bracket, and that's 209. And for Y, make it bold, equal the units damaged value, and that is for December 1999. So divided by seasonal index for December. And let's round that to the whole number. Okay, so X equal 209 and Y equal 305. Which time series component appears in the deseasonalized data to a greater degree than in the centered moving average? So deseasonalized data doesn't have season. The seasonal index has been divided, so it doesn't have seasonal index. Let's add this deseasonalized data range to our chart. So edit the chart, and for the data range, add another range, and that range will be deseasonalized data. Click on OK. And for the series, click on Add Series, click on Deseasonalized Data. So as we can see, the seasonal index has been removed. So what we are left with is the irregular component. So we are left with irregular component.